Hello and welcome to a video presentation on prime factorization. Here's what you'll learn. How to find the prime factorizations of composite numbers. First of all, what is prime factorization? Well, before we get into that, let's define a few key terms. First of all, factors. Factors are numbers multiplied together to give us a product. For example, if I took 2 and 23 and multiplied them together, I would get 46. That means 2 and 23 are two factors of 46. If I multiply 2, 3, and 10 together, I get 60. So 2, 3, and 10 are three factors of the number 60. What's a prime number? A prime number is a whole number whose only factors are 1 and itself. Take the number 2, for example. What numbers can I multiply together to give me a 2? There are only two numbers. 1 and the number 2 are the only two numbers to multiply together to give me a 2. Take the number 11. What numbers can I multiply together to get 11? The only two numbers are 1 and 11. So 2 and 11 are just two examples of prime numbers. What's a composite number? A composite number is a whole number that has more than two factors. For example, let's take the number 6. What numbers can I multiply together to give me 6? Well, I could multiply 1 and 6 together, or I could multiply 2 and 3 together. Either one of those will give me 6. Take the number 24. What can I multiply together to give me a 24? 1 times 24, of course, or 2 times 12, or 3 times 8, or 4 times 6. Any of those expressions will give me the answer 24. What's a factor tree? Well, a factor tree is the method I'm going to be using today to find the prime factors or the prime numbers that make up a whole number. Factor tree structures look like branches on a tree. For example, here's the factor tree for the number 42. The numbers right under the 42 are 2 and 21. Those are two factors of 42. Underneath that, I've broken 21 down further into 3 and 7. The numbers at the very bottom of the tree are 2, 3, and 7. They're all prime numbers, so they are the prime factors of 42. And the red lines that connect all the numbers, those are the branches of our factor tree. Prime factorization is breaking down composite numbers into a list of prime factors or prime numbers. Let's use a factor tree to find the prime factorization of the following number, 42. Now let's start by writing down 42, and let's break it up into, say, 6 times 7. 7's already prime, but 6 isn't, so I can break it down further into 2 times 3. And to make sure we don't miss any of our prime factors, let's pull them all down to the same level. So that 7's hanging up there. Let's pull it down to the bottom of our factor tree. And down at the bottom, we have our prime factorization for the number 42. 42 is made up of 2 times 3 times 7. Now, to show you that we don't have to use any particular combination of factors, let's do 42 again. But this time, let's break it down into 21 and 2. And show we get the exact same answer. 2 is already prime, but I can break 21 down into 3 times 7. Don't forget to pull that 2 down to the lower level of our factor tree so we don't forget it hanging up there in our factor tree. And we have the exact same numbers, a 3, a 7, and a 2. And we should always write the prime factorization in order from least to greatest. So we see the prime factorization of 42 in this case is exactly the same. 2 times 3 times 7. Either one works. Now let's find the prime factorization of the number 300. I'm going to write down 300, and I'm going to break it down into 10 and 30. Neither one of those numbers is prime, so they'll break down further. We can break 10 down into 2 times 5. 30 we can break down into 6 times 5. Now both 5's and the 2 are already prime. 6 is composite. That means I can break it down further. 6 breaks down into 2 times 3. Now let's pull all of our prime numbers that are higher up in the tree down to the bottom. We'll pull our 2 down, pull our first 5 down, and pull the 5 at the end down. Now all of our prime factors are at the bottom. They're not in order, but we should write them in order. So the prime factorization of 300 is 2 times 2 times 3 times 5 times 5. Or if you wanted to use exponents and shorten up your answer, we have 2 2's, so we can say that's 2 to the second power, times a 3, and we have 2 5's, so multiplied by 5 to the second power. Let's find the prime factorization of the number 884. Let's write it down, and I can break it down into 52 and 17. 17's already prime, but 52 is composite, so I know it'll break down further into 4 and 13. Now 13 is prime, 4 is composite, so I can break 4 down further into 2 times 2. Don't forget to pull your prime factors that are higher up in your tree down to the bottom, so we don't forget any of them. Pull 13 down, pull 17 all the way down to the bottom, and now it's easy to see our prime factors. They're already written for us in order in this case, but if not, you should write them in order. The prime factorization of 884 is 2 times 2 times 13 times 17. Or, since we have 2 2's, we could write it using exponents. 2 to the second power times 13 times 17. Congratulations! You've learned how to find the prime factorizations of composite numbers.